All right, hey there, guys. Today we are going to be talking about spatial autocorrelation. All right, so spatial autocorrelation is defined as the cross correlation of a set of values with themselves over space. Hold up, though. Hold up. That just sounded like a bunch of words. Let's break it down. All right, so basically, it's when data is correlated spatially with itself, which kind of makes sense if we think about Toppe's first law of geography, which is everything is related to everything else, but near things are more related than distant things. I mean, let's think about it. So, in some situations, it's very natural for things to be clustered in space. Like take for example, like pack animals or fast food restaurants, like right off the side of interstates, very clustered in space. Um, but let's look at some actual data. So here we have beer and church tweets by county. More beer is blue and more church is red. We can clearly see there is some clustering. So we got nice red in the south, and oh, look at that, in the north there's lots of beer. But so there's definitely some spatial autocorrelation going on here. The next county over is more likely to be one or the other, depending on its neighbor. And while it's all good to visualize it like this, we're geospatial scientists. We gotta use math. All right, so let's do some math. Let's do some math. So on the topic of beer, here is a map of the number of breweries, wineries, and distilleries by census tract in New York State. And we want to find out if this data is spatially autocorrelated. So we are going to run a statistical test to see if this data is spatially autocorrelated. To interpret it, we'll look at the p-value and then decide whether to reject our null hypothesis or not. And our null hypothesis is that our features are not clustered, they are dispersed. So let's look at the output of that test. And here we see that the p-value is 0.000045. So this p-value is very significant, and we will reject the null hypothesis, meaning that this data is clustered, it is spatially autocorrelated. So why is this important? Come on. Like, why do we need to know if things are clustered? Why run statistical analysis on it? Like, what's wrong with just looking at it and being able to tell? Well, first of all, sometimes you can't tell, and second of all, if you want to get money from someone for your project, you better have the math to back it up. But I mean, that being said, sometimes sometimes you don't want your data to be spatially autocorrelated. Like for example, if you're building a regression model, you do not want that model to be autocorrelated. So basically, like what the regression does, it's going to predict values, and then if you have a large clustering of spaces that are over predicted or under predicted, that's bad. So this is a bad model because your over predictions are very correlated and clustered. Um, and yeah, that's spatial autocorrelation. Thanks, guys.